The Earth's crust is a shell of solid rock. We live on the crust, but we do not see much of it. Most of it is covered with soil and oceans. Beneath the crust is a region called the mantle. It's made up of rock that is so hot that it is molten. The name for such rock is magma. Once the rock reaches the surface, it's called lava. Earth scientists used to think that the Earth's crust was all one piece, like the shell of an egg. Now they think it's broken into a number of huge slabs, which they call plates. Each plate is made from rock of the crust and rock of the upper mantle. These plates are in motion, moving a few inches each year. As the plates move, they carry with them whatever is on top of them, the ocean floor, islands, and whole continents. There are places where the plates pull away from each other. Here molten rock wells up and sometimes volcanoes erupt. There are also places where plates collide. One plate turns down and slides beneath the other into the mantle. Here the rock melts, magma rises, and volcanoes may erupt. In our Pacific Northwest, a small eastward moving ocean plate collides with and slides beneath a large westward moving plate carrying North America. Here volcanic eruptions have built the Cascade Mountain Range, a chain of volcanoes that runs from northern California into British Columbia. Mount St. Helens in southern Washington state was long considered one of the most beautiful mountains in the Cascade Range, with its gleaming snow-capped peak that formed an almost perfect cone. For many years, Mount St. Helens slept. It was silent and still, big and beautiful. Then the volcano began to stir. On March 20th, 1980, it was shaken by a strong earthquake. The quake was a sign of moving magma. It was a sign of a waking volcano that might soon erupt again. For 2 months, the mountain gave off steam and ash. As geologists monitored it, they discovered a huge bulge growing on the north slope. On Sunday morning, May 18th at 8:32, Mount St. Helens erupted. Billowing clouds of smoke, steam, and ash hid the mountain from view and darkened the sky for miles. By the eruption's end, a fan-shaped area of destruction stretched out to the north, covering some 230 square miles. Within that area, countless plants, animals, and 57 people had died. The May 18th eruption began with an earthquake. Shaken by the quake, the bulge tore loose, ripping open the side of the mountain and sliding away as a gigantic avalanche. The avalanche hit a ridge and split. One part of it poured into Spirit Lake, adding a 180-foot layer of rock and dirt to the bottom of the lake. The main part of the avalanche swept down the valley of the North Fork of the Toutle River. There, in the valley, the avalanche slowed down and stopped. The avalanche covered 24 square miles. Within seconds after the avalanche began, a scalding blast of steam and volcanic gases shot sideways out of the opening. The blast carried rock shattered inside the mountain, forming a wind of stone that traveled at speeds of up to 200 miles an hour. The rocks, ranging in size from grains of sand to blocks as big as cars and traveling at high speed, gave the blast its great force. The stone wind stripped bark and branches from trees and uprooted them, leveling 150 square miles of countryside. Minutes after the blast, Mount St. Helens began to erupt upwards. A dark column of ash and ground-up rock rose miles into the sky. Winds blew the ash eastward. Lightning flashed in the ash cloud and started forest fires. Shortly after noon, the volcano began giving off huge flows of pumice and ash. The material was very hot, with temperatures of about 1,000 degrees Fahrenheit, and it traveled down the mountain at speeds of 100 miles an hour. The flows formed a wedge-shaped plain of pumice at the base of the mountain. Mud flows started when heat from the blast melted ice and snow on the mountaintop. The water mixed with ash, pumice, ground-up rock, dirt, and rocks of the avalanche. The result was a thick mixture that was like wet concrete, a mud flow. The mudflows traveled fast, scouring the landscape and sweeping down the slopes into river valleys. Together, their speed and thickness did great damage. The largest ripped houses apart, tore out steel bridges, and swept up huge boulders. When the sun rose on May 19th, it showed a greatly changed Mount St. Helens. The mountain was 1,300 feet shorter than it had been the morning before. The north side of the mountain had changed from a green and lovely slope to a fan-shaped wasteland. On Mount St. Helens, there was a big new crater in the shape of a horseshoe. Inside the crater was the vent, the opening through which rock and gases erupted from time to time over the next few years. In 1980, Mount St. Helens erupted 6 more times. Most of these eruptions were explosive. Ash soared into the air, and pumice swept down the north side of the mountain. During this time, geologists were learning to read the clues found before the eruptions. They learned to predict what Mount St. Helens was going to do. The predictions helped to protect people who were on and near the mountain. To learn what the volcano might do, scientists made many kinds of measurements, trying to follow the movements of magma inside Mount St. Helens. Many were made inside the crater. Here, scientists can be seen on the lower left. The dome, a mass of hardened lava that surrounds the volcanic vent, is to the right, the crater wall to the left. With his instruments shielded from the sun, this geologist is measuring the swelling of the dome. Swelling may be a sign of an eruption building up. When magma moves, it causes earthquakes. These scientists are installing a seismometer which senses earthquakes. Scientists also sample the gases given off by magma. A sharp increase in sulfur dioxide often tells of a coming eruption. In 1982, Congress set aside 110,000 acres around the volcano as the Mount St. Helens National Volcanic Monument. Outside the monument, bulldozers could clean up and forests could be replanted. Inside the monument, little was to be changed so that scientists could study what had happened and what was happening at Mount St. Helens, so that visitors of all ages could see the effects of the eruption and the return of life. Among the first visitors were many natural scientists. They had come to look for survivors, for plants and animals that had lived through the eruption. They had come to look for colonizers, for plants and animals that would move in. Mount St. Helens had erupted many times before 1980. Each time, life had returned. Now scientists would have a chance to see how that occurred. They would see how nature healed itself. In the early summer of 1980, the north side of Mount St. Helens looked like the surface of the moon, gray and lifeless. The slopes were buried under mud, ground-up rock, pumice, and shattered trees. Ash covered everything with a thick crust. The slopes looked like a place where nothing could be alive or ever live again. Yet life was there. With the coming of warm weather, touches of green appeared among the grays and browns, the green of plants that had survived the force and heat of the eruption. Some plants had still been buried under the snows of winter on May 18th. Huckleberry and trillium sprang up among the fallen forest trees. In other places, roots, bulbs, and stems remained alive underground. They sprouted, and hardy shoots pushed up through the pumice and ash. Among these was fireweed, one of the first plants to appear after a fire. Fireweed appeared through cracks in the ash. Sedge grew through the crust of ash. Some small animals had survived underground. There were chipmunks, white-footed deer mice, and red squirrels. There were pocket gophers, small rodents that carry food in fur-lined pockets in their cheeks. Ants also survived underground. So did eggs laid by insects. Many other small animals, such as springtails and mites, lived through the eruption in their homes of rotting logs. Meta Lake, here shown in 1984, was protected by a cover of mushy snow and ice at the time of the blast. Its frogs, crayfish, and other animals were survivors. Natural scientists also found many tiny living things. They found countless numbers of bacteria. They found fungi, which are very simple plants. Fungi cannot make their own food as green plants do. They take their nourishment from other living things or from once living things, like rotten wood. Fungi can reproduce in several ways. One is by making spores, which are as small as specks of dust. Fungus spores are everywhere. When conditions are right for them, they sprout and grow. Scientists at Mount St. Helens saw fire fungi, which often appear after forest fires. Their spores need great heat to sprout. Both fungus spores and bacteria are very light. They can travel thousands of miles on the wind. In that first summer, scientists saw many other colonizers arriving. The earliest came by air. Light seeds of willow and cottonwood blew in. Insects blew or flew in, and spiders ballooned in. The scientists also saw animal visitors. Birds flew in. Coyotes, elk, deer, and other large animals passed through, perhaps looking for food and water. That first summer, there were not many plants and animals on the North Slope, but there was a wide variety, so natural scientists were able to start studying the links among these forms of life. For no living thing exists all by itself. Each is linked to other living things and to its surroundings. All need food and places to live. Scientists saw important small changes taking place in the summer of 1980. There were areas where snow lay under the ash. When the warmth of summer melted the snow, it no longer supported the ash. The ash slumped and broke up. Here, surviving roots could send up shoots. Heavy rain sent water running down the slopes. The water cut channels in the ash. Here, too, roots could send up shoots. Huckleberry plants thrived in a channel cut by running water. Deer, elk, and other animals wandered through, some feeding on plants. Many times, scientists did not actually see the animals, but saw tracks or other signs of them. They saw coyote tracks, the tunnels of meadow voles, deer tracks, and killdeer tracks. They saw a Pacific silver fir, a survivor, stripped of bark, a sign of a porcupine. They saw the tracks of a bear that had been eating huckleberries and then wandered up the mountain, perhaps looking for more food. Although some plants were eaten, animal visitors brought in seeds of other plants. Some seeds were stuck in their coats, others were in their droppings. The animal tracks made hollows that trapped seeds and offered a place where seeds could sprout and plants could grow. In time, these plants would form seeds. The seeds would colonize other places, and every plant that grew would help other forms of life. In the summer of 1980, a few hardy plants, like this lupine, were islands of life, places where insects and spiders found food and shelter. Some meadows and areas of clear-cut forest had groups of plant survivors. With them were animal survivors, white-footed deer mice and pocket gophers. The mice ate seeds and insects. The gophers, which lived underground, ate roots and bulbs, but they also did something that helped plants. Gophers were tunneling in soil that was now covered with ash and pumice. By shoving soil out of their tunnels, they brought it to the surface. The piles of soil became places where seeds could put down roots and plants could grow. When the plants grew well, their roots served as food for the gophers. Above ground, the seeds of these plants spread and started still more islands of life. Some ants found food in islands of life. Other ants had survived in places where there were no islands. They may have had some food stored underground, but to go on surviving, they needed to find food above ground. That food turned out to be fire fungi. The fungi formed mats of tangled threads that lasted for months. The fungus mats also served as seed beds for other plants. By the summer of 1981, the fire fungi were gone and mosses were growing in their place. Mosses and other low-growing plants trapped seeds on their rough surfaces. The seeds sprouted and grew into green plants. Green plants are the only living things that can make their own food, so nearly all other forms of life depend on green plants for food. Some take food from the plants, others eat the eaters of plants. In making their food, green plants take minerals from the soil. Minerals never get used up because they are recycled. They go back into the soil after animals or plants or parts of plants die. The minerals are released as the dead material rots or decays. Decay is caused by many small forms of life, such as bacteria, fungi, mites, springtails, beetles, and millipedes. Through their feeding, they break down dead material. Minerals go back into the soil. At Mount St. Helens, these small forms of life broke down the remains of animals and plants killed in the eruption. They broke down the droppings of animals as well as leaves and stems when plants died back in autumn. Minerals were released and used in new plant growth. Even the bodies of insects help plants to grow. On the surface of ash and pumice, scientists could see the molts and dead bodies of insects, many of which are short-lived. The scientists were surprised at the amount of carbon and other minerals in the molts and bodies. They realized that insect bodies have always enriched soil. Insects and other small animals were food for the first birds that returned. Natural scientists think that all the birds on the north side of Mount St. Helens were killed on the morning of May 18th. Later that summer, there were many bird visitors, but at first only a few kinds of birds could live and breed in the area. Among them were juncos, which nest on the ground, and woodpeckers, which nest in holes they make in trees. Once woodpeckers have raised their young, they desert the nest holes. Deserted woodpecker holes helped mountain bluebirds to return. Bluebirds also nest in holes, but they cannot make their own. They must find holes that have formed naturally or that have been made by other animals. Both fish and water insects need oxygen. In many lakes, there was little oxygen during the first few years after the eruption. They were filled with trees and bits of plants. Billions upon billions of bacteria and other tiny living things were in the lakes, feeding on these materials, feeding on one another, and using up the oxygen. Surviving fish had to live near the surface, where winds stirred the water and added oxygen to it. They did not find much to eat. That first summer, there were two main insect foods for fish. One was the rat-tailed maggot, the other young mosquitoes. Both have breathing tubes and can take oxygen from the air. The May 18th eruption wiped out most large forms of life on the north side of Mount St. Helens. The healing of the slopes started with many small forms of life. There were bacteria, fungi, hardy weeds, and seeds. Insects, spiders, and pocket gophers. Linked together, they formed a base that made possible the return of other kinds of life. By the end of the first summer, some survivors had died, but others were still alive and well. Colonizers had been arriving steadily. Sometimes the air was silver with clouds of insects and seeds. Life was coming back to the volcano as it had many times before. Fireweed sprouted through the ash and developed flowers which produced seeds that blew away on their silvery fluff and gave rise to new plants. One day, 100 years from now, a new forest will be growing on the north slope of Mount St. Helens. Everything that lived on the slope before May 18, 1980, will be able to live there again. Volcanoes destroy some life when they erupt, but they also help to make life possible. Volcanic eruptions add gases to the atmosphere and water to the ocean. Volcanoes are builders of land. Floods of lava have built big chunks of continents. Volcanoes build some of the Earth's mountains and some of its islands. Volcanoes are also makers of soil. Ash, pumice, and other forms of lava break down in time. They mix with the remains of plants and animals, making a rich soil. The soil nourishes plants, which support many other forms of life. Volcanoes destroy, but they also build. And after each eruption, life does come back, finding small footholds and spreading. Scientists were awed by how quickly life appeared at Mount St. Helens, sometimes in the most unlikely places. One natural scientist visited the crater after the explosive eruption stopped. Near him was a rock the size of a small house. The rock, which had erupted from inside the mountain, was a new part of the Earth's surface. He found that algae, simple green plants, were already growing on the rock. He saw a ladybug. He found a moth that was the same color as the rock. Finally, he discovered a little opening in the rock where a bird had spent some time, perhaps an evening. There were its droppings, which contained the remains of insects. All this life, the scientists said in wonder, on just one rock. That life, like the islands of life and the silver clouds of seeds and insects, is a promise of the time when Mount St. Helens will once more be a green and pleasant mountain, home to many kinds of plants and animals.